Let's consider an example we did in class, and that was the following. We had someone trying to jump an alley, and then running off on one side at horizontally at an unknown speed v0, and we assume that this building is 20 meters tall, and he's supposed to make a ledge, a window, which on the other side is 1.5 meters lower, and the alley itself is 7 meters wide. And the question now that we have is find v0, so the initial velocity at which he has to run off the roof horizontally in order to make that jump. So the jump goes like this to that ledge. Let's look at the things we know already. Let's define a coordinate system first. So I can, for example, define a coordinate system with a vertical y going upwards and x in this direction. With this coordinate system, the person starts at a value x0 equals 0. We know that. We know that the final x position equals 7 meters, or in other words, the same thing, delta x is 7 meters, which is x minus x0. v0 x, that's what we're supposed to find, so we don't know that. We also don't know what the final x component of the velocity is. As long as we can neglect air resistance, we know that there's no acceleration in the x direction. We also know that the initial position in the vertical direction is 20 meters. The final position in the vertical direction is 20 meters minus 1.5 meters, and that equals just 18.5 meters. Or in other words, we can also say that delta y equals y minus y0, and that is just minus 1.5 meters. So 1.5 meters lower. Running off the roof horizontally, so v0 y, the initial component, is 0. We don't necessarily know what the final velocity will be, and we know that ay is minus g because you define positive y going upwards. We're supposed to find v0 x. So let's look at all the equations that we know that have v0 x in them. First that comes to mind is x equals x0 plus v0 x t plus 1/2 ax t squared. We also know that vx equals v0 x plus axt, and we know that vx squared equals v0 x squared plus 2ax times delta x. Let's check off the things that we know and that we do not know. So in the first equation, we know what x and x0 are. We also know what ax is. However, we do not know what v0 x is. Also, we don't know how long this will take. So this equation contains the variable we're looking for and the unknown t. In the second equation, we do know what ax is. It is 0. We don't know what vx is and what v0x is. We don't know what t is. Likewise, in the third equation, we don't know what these quantities are. We do know, though, in the last equation again what ax is, and we do know what delta x is. With ax equals 0, the last two equations actually turn into something very simple. So it follows from that is just that vx equals v0x. The trivial statement, the final x component is the initial x component if the acceleration is 0 in this direction. It follows from both of these equations. So they are both no good in finding the correct answer. So what we have to use is we have to use the first equation to find this. From the first equation, now it follows that x minus x0 equals v0x times t, and from that it follows v0x equals x minus x0 over t. We know what x minus x0 is, so this is just delta x over t. So we need to find t first. Need to find the time. We can't find the time from any of the other two equations. The second one, if we multiply with ax equals 0, doesn't have the time. The third one doesn't have the time at all. So we have to go to the y direction in order to find the time for the problem. We look at this, we find that y equals y0 plus v0y t plus 1/2 ay times t squared. That equation contains the time. Also, the other equation that contains the time is the one with vy equals v0y plus ay times t. If we look at the quantities that we do know, we know what y is, the final vertical position. We know the initial one. We know what v0y is. It is 0. We know what ay is. The only thing we do not know in this equation is what the time t is. Actually, I should have used question marks all the way on top here too. So these here actually should all be question marks because I don't know what these quantities are. I made them red instead of just question marks. The second equation, let's briefly look at this. The second equation, we do know what ay is. We do know what v0y is. However, we don't know what vy is, and we don't know what t is. So there are two unknowns in there. So the equation that will allow us to get to the time is actually the first one that we wrote out here. If we plug in the things that we know, from that it follows y equals y0 plus v0y was 0 times t, and then we have minus 1/2 g times t squared. So from that it follows that y minus y0, which is just delta y, is minus 1/2 gt squared. From that it follows now that 2 delta y, I multiply left and right with 2, then I divide by minus g also left and right. That is t squared. So what we find is that t equals 2 delta y divided by minus g and the square root over it. It is 2 times minus 1.5 meters divided by minus 9.81 meters per second squared, and from that we get 0.553 Let's look at the units. What we get meters divided by meters per second squared and the square root over it. So the units is seconds as expected for a time. So now that we have that, we can go back to the equation that we found for v naught x. From that it follows now that the initial speed that we need is just our delta x divided by the time. Delta x was 7 meters and the time was 0.553 seconds, and that gives 12.7 and the units meters per second as expected for a velocity. So if the person runs off the roof at 12.7 meters per second, they will just make it to this ledge 1.5 meter below.